My name is Don, VE9ZP, and I've been an amateur radio operator for a little over a year. And this is going to be my very first PowerPoint presentation, so please bear with me, and we'll see how it goes. I guess I can do that, and then hopefully this will work. Just like to talk for a couple of seconds here on what grounding and bonding are. The word grounding, meaning a connection to the earth, is casually applied to so many different purposes in amateur radio. It's no wonder there are many opinions and misconceptions about it. Now, bonding is a less familiar term to most amateurs. In the electrical sense, bonding simply means to connect together so that voltage differences between pieces of equipment are minimized. And that's the key, is to minimize the voltages between equipment. Now, a little blurb on homemade and vintage equipment, as a lot of people do have. You should take extra care when connecting homemade and vintage equipment to AC power. Both can present significant shock hazards from insulation failures or miswiring. And you can make a good visual inspection and use an ohm meter to verify that all connections are secure and that there are no short circuits between primary circuits. And that's those connected to the AC line and the chassis. Okay. Now, you should replace any two-conductor AC cord with a 3-wire grounded cord, unless the equipment is an AC-DC transformerless type. And that would be just with a 2-prong plug. Primarily, they have a plastic chassis, so there isn't any danger of getting shocked.
Is there a picture that goes together with what you're saying, Don? Because we're just looking at your introduction.
Yeah, no, it's this is sort of a little prelude to the actual presentation. Now, antique transformerless equipment with one side of the AC line connected directly to a metal chassis was developed to operate from either AC or DC power. And the way to operate this equipment safely is to power it with an isolation transformer. Now, ensure that the insulating cover over the chassis is intact and none of the control knobs or switches have set screws that could contact the metal shaft of the control mounted to the chassis. And just a little bit here, how much current is dangerous? I don't know if everybody's up on this, but AC currents above 50 milliamps flowing through the human body can be hazardous. At regular household voltage of 120 volts, any resistance below 2.4 megohms allows 50 milliamps or more to flow. Since the body typically presents several hundred kiloohms or less between 2 points on the surface, any contact with household voltage is a significant hazard. Now, the amount of risk from the current depends on where it's flowing. Unlike radio frequency currents that flow along the surface of the skin, DC and low frequency AC currents flow through the body's tissues. Now, the most hazardous paths are those that go directly through the heart, and such as hand-to-hand and hand-to-foot paths. Now, the static voltage created by friction from clothing or just brushing hair can be hundreds or even thousands of volts, static electricity. Yet the amount of charge that actually flows is pretty small and has a little limited effect on the heart and other muscles, because you just feel that little bit of a zap, and that's basically it. Now, the hazard comes from the effects of current flowing, not the voltage that causes the current to flow. So with that being said, now we're all pretty up to snuff on grounding, bonding, and a few other little things. Now, most new hams who operated mostly in the VHF and UHF band enjoyed their operating until later, when they upgraded to the HF bands, and probably immediately cropped up, and problems immediately cropped up. The first time they pressed the push to talk and started talking in front of the microphone, all active equipment in the shack went haywire. Panel meters went crazy. The power supply voltmeter jumped up and down. And if he was unlucky, he may have got his first microphone bite to shock him by surprise if the base microphone case was metallic. Now, organizing an effective grounding system in the ham shack requires the ham operator to address the two major aspects of grounding. And they are, number one, compliance with electrical safety guidelines, electrical grounding system. And second of all, dealing with RFI in the shack, and that's RF grounding system. Now, in general, most newcomers to ham radio do comply with the first aspect in the context of electrical safety, but often neglect the aspect of reducing the excessive presence of RF energy within the shack. Many believe that complying with good electrical safety guidelines is enough to dispel other operating problems. Not so. This notion is false. Some of the problematic signs and symptoms of poor RF grounding in the shack that degrade the quality and satisfaction of operating ham radio equipment are as follows. Microphone bites, a nasty RF shock when you have the microphone up to your lips, a gritty and or fuzzy modulation, just distortion, a malfunction of electronic keyer, RF shock when touching metallic objects within the shack, power supply jitters, the regulated power supply becomes unregulated, and crazy SWR meter readings. And there's a number of others, but those are primarily the most prominent ones. Now, all of these are major signs and symptoms of the presence of high RF voltages within the immediate vicinity of the ham shack where the transmitter is active. And these are all attributed to poor RF grounding. All conducting objects will absorb RF energy through coupling and will re-radiate the same. One can say, but I already have a very good electrical ground. True or not true? If you experience any of the above problems within the shack, I'm pretty sure that you're suffering from a plethora of grounding and ungrounded ham shack problems. Now, I got a scenario here. This ham operator was a neat fellow. One day, he finally convinced the XYL to let him set up his own radio shack, away from the prying eyes and itchy fingers of the family kids. And so he built his own radio room on the ground floor of the home, QTH. He arranged his equipment, built a good electrical ground system by laying out a heavy copper wire about 3 meters long just behind the neatly lined up station equipment. Now, he decided to run the ground wire straight so that each equipment ground lug can accommodate a short flexible grounding wire to reach the ground bus. He did this to all the station equipment, and it was a very neat connection, okay? And the grounding wire didn't get messed up or anything, and the remaining length of the ground bus was led outside. That was to an effective ground rod placed just outside near the wall of the radio room. Now, this grounding setup looks something like this, what you see on the screen right now. Now, I'm asking this, is this a proper way to ground the shack? Wait for the answer on that. When everything was in order, he fired the 100-watt transceiver up and began transmitting by calling another station on 20 meters. To his surprise, the station operator at the other end responded to tell him that his signal was S9, but the audio was garbled, gritty, and fuzzy. Further adjustment and tweaking the ALC and mic gain controls didn't do anything to solve the problem. So he further observed that by reducing the RF power to 50 watts, the problem disappeared. But when he switched on his amp to give 250 watts peak envelope power output, the problem returned and became even worse. The two stations spent almost 2 hours adjusting this and that and tweaking this and that, but they couldn't get anything to solve it. And just as our good and neat fellow ham was about to retire after a frustrating day, a third ham who had been monitoring the exercise came on frequency and then politely said, You may be suffering from a poor ground. And the problematic ham answered, what? I have a perfect ground system. He then described his new and neatly connected grounding setup. Third ham said, you may have ground loops. Then he proceeded to explain why, during the long QSO exchange, the problematic ham learned the following. Now, ground loops are formed when the individual ground wires of each equipment are connected to the main ground bus at a point that is distant from each other, such as this example. The individual station equipments already have their own ground reference, but when they're interconnected, grounding each equipment to the main ground bus, as shown in this figure, creates ground loops. And each time a ground loop is created, a small inductive coil is formed and the ground wire completes the loop. Now, when the ground loops are in the near field of RF energy during transmit mode, these loops will couple to the RF energy, called RF coupling. As the RF energy is coupled to each loop, a fluctuating voltage is induced in unison with the burst of audio modulation of the RF energy. Now, this energy will flow within the system and will seek the least resistance by following the associated circuits and eventually creeping into other internal circuits. Once the RF is inside these circuits, it'll interfere with the normal operating parameters of sensitive circuits, thereby creating havoc. RF bleed over escaping from long interconnecting coax cables may also flow within each loop, bathing the whole shack with the RF energy. And that would be your final result. Now, his new ham shack had an excellent DC electrical ground system, but very poor RF ground system. Excuse me. Now, finally, the fellow ham, he suggested to him to try the following. Dismantle the present ground wire configuration. Remove the long bus, the long ground bus, and terminate all ground wires from each equipment into a single point near your ground rod. Now, the problematic ham scribbled quickly on a piece of paper and came up with the final wiring that looked like this circuit. You have all your grounds coming together at a single point. Now, they both agreed on the modifications and promised to contact each other at the same time the following day, and then they signed off. Came the following day, contact the problematic ham called the Elmer and got an immediate reply. Hey, old man, the Elmer said, you have a beautiful signal, clean and kicking. After a short pause came a reply, yep, thanks. They exchanged an extended pleasant QSO and finally parted. The audio problem was solved and he was happy ever after. Now, case number, or here's another scenario. One day, one day during the next several rag chew sessions on the same band, a third station joined the QSO. Now, his signal was strong, but the audio was also thin, fuzzy, and garbled every time he raised his voice over the microphone. RF was all over the ham shack. He told the Elmer that every time he spoke over the microphone, the voltmeter of his regulated power supply jumped up and down the scale. The screen on his computer became fuzzy, and his lips were bitten with electrical shock if they touched the metallic case of the microphone. Now, one night while working at DXQSO, his ex-YL came to the shack to give him the regular goodnight kiss. And holy cow. She and he received a mild electric shock the moment her lips touched his earlobe. Also, he was threatened several times during the early evening QSO sessions by marble-sized stones dropping and rolling down his rooftop, apparently thrown by close neighbors irked by the RFI to their TV, stereo, and radio sets. Each time he transmitted, his Donald Duck's voice was heard over their radio sets. Well, he told the Elmer that he was monitoring silently, just reading the mail, so to speak, the previous exercise in scenario 1, but did not bother to break in so as not to disrupt the lecture over the air. Now, nevertheless, he told the Elmer that he followed to the letter the previous over-the-air advice, but still his station suffered from serious RFI problems within the shack. After describing his grounding setup, the Elmer said, "Aha, you have an ungrounded ground." Now you're thinking, an ungrounded ground, how is that possible? Well, but he has a ground. Okay, and while listening meantime to the surprised ham, the Elmer drew in his mind the setup as described. This ham had a shack installed on the second floor of the house. The single heavy ground wire was quite long and extended diagonally to reach the ground rod that was nearly 30 feet down to the far outside corner of the ground floor. Now his ground system, okay, by the way, excuse the picture, it's actually 90 degrees tilted, but that is my grounding system in the shack, where I have the single point of the bare copper wire coming in to the ground bus. And then the green insulated cables, they are all going to my respective bits of equipment. So just so that you know there. Now, his grounding system looked kind of like this, okay? Where you've got everything single point ground, but he's got a 30-foot length of ground wire going to the ground rod outside. Now, in the next over, the Elmer said, "It'll take a long time to discuss the reason why you have an ungrounded ground system." But anyways, he emailed him, and it turned out that the 30 feet is basically, it acts as an antenna. And so therefore it's picking up the RFI and redistributing it through the system again. As we go back to Mr. Ohm's power formula, the voltage that appeared at point B would be determined by the following parameters. And I can't remember how to get back. Anyways, the power of the transmitting equipment and the equivalent impedance value at point B, the length of the ground wire in wavelengths, and the extent of RF to earth ground leakage existing in the whole setup in the shack. And we can generally calculate that right from good old Ohm's Law there. Now, we come to another scenario here. Further to our previous QSO, herewith please read and understand the explanation why your ground setup is ungrounded. And to understand, please examine the drawing of this electrical equivalent as shown here. The Elmer continued, your ground wire is 30 feet long, 9.1 meters. Now this length is very close to a quarter wavelength, that's 7 megs. When you start transmitting at that frequency, your transmitter set up an antenna system will create an image of standing wave throughout the length of this wire. Easy stomach. This is by virtue of the RF voltage induced due to resonance. If the long ground wire is a quarter wavelength long at the transmit frequency, this wire will resonate and act as a radiating element. If the ground wire is less than a quarter wavelength, it will appear as an inductive reactance, the value of which is 0 at earth ground and high at the circuit ground point in the equipment. Now, if the wire is exactly a quarter wavelength of the transmitting frequency, the ground wire will act like a resonant LC circuit with very high impedance at its top point, and this reactance will appear like a resistance called impedance to impede the flow of RF current to earth ground. Now that brings the earth ground of all station equipment to float above the earth ground as if the ground wire is not there, or as an insulator at RF. So that is something that you definitely want to watch out for. If you do have a shack on the second floor, try and keep your ground as short as possible. Now, there's an RF suppression ground system. This is a modern version of an ingenious device developed and introduced by several hams in recent years, notably by William Chesney, November 8, Sierra Alpha. This grounding system addresses both the electrical ground and the RF grounding requirements in ham radio. The device is intended for long grounding wires. So this is perfect scenario for this setup. The grounding device utilizes a coax line where the ground wire is enclosed by a shield, such as RG8 transmission line, to prevent the buildup of high voltage standing wave near the station equipment. Now, this ground line is not length sensitive and can be used at any length without concern. It'll keep out RF away from the shack, and the wiring setup of this is shown here. Now, you would remove the existing ground wire and replace it with the length of RGA coax transmission line, enough to reach the ground rod and into the shack to connect to the ground bus. At one end, short soldered together, the coax shield to the center conductor of the RG8, and the remaining pigtail will be connected, soldered to a short, heavy gauge, solid copper wire to reach the ground rod. At the other end, strip the coax to reveal the center conductor and remove part of its shield. Connect the center conductor to the circuit ground of the equipment. Leave the coax shield open at this end, but connect a ceramic disc capacitor on one of the terminals. Or sorry, one terminal of this capacitor is connected to the coax shield and the other terminal to the center conductor. And there you have it. The RF suppressor ground system is now complete. And of course, the capacitor value is selectable depending on the lowest operating frequency band and length of coax. The correct value is selected until RF disappears in the shack at the lowest band, or when your lips don't get that burned or electrocuted feeling when you touch the mic. Now, you must use a high voltage capacitor rating, about 1 kV minimum, but the higher the better. Otherwise, you're going to fry that capacitor. And it will explode if a surge of high voltage standing wave will develop instantly at or above 500 volts at this terminal. Now, just like to say it is important to realize that grounding and bonding deal with voltage and currents spanning a very wide range of frequencies and wavelengths. Now, the energy of a lightning strike is centered around 1 megahertz, spread out from DC to 10 megahertz or higher. For amateur RF, current and voltage management involve frequencies from medium frequency right into the VHF, UHF region. Now, amateur station wiring practices also affect tiny received signals of a few microvolts all the way to the kiloamp and kilovolt pulses of lightning. And with such a wide variety of signals involved, no one-size-fits-all technique satisfies every need in every circumstance. By being aware of the different needs, though, you can understand each ground connection, or you can understand each ground connection from the various points of view that are involved. And that's just a couple of a couple of examples of my grounding setup here. And that is a proper ground system setup right there. That's not mine. That was taken from a screenshot. And that was excerpts from the following: Mike Morgan and Tim Elison. I thank you very much, gentlemen, for your words of wisdom. And there we have the evolution of ham radio, starting right from the wheel. And that is the presentation on grounding and bonding. So I hope everybody was interested. I hope I didn't put anybody to sleep. Now, do we have any questions?
A question, Don. It's Art.
Yes, sir.
In the case of that long ground wire from maybe the second floor ham shack, the capacitor you showed there, is that a fixed capacitor, or would you tune that to null out the inductance from the wire at different frequencies? So would it have a different setting with each band you were on, or each part of some extra broad bands?
If you worked multi-band, it would be advisable to go with a tuning type of capacitor. But if you're primarily working on one band, one frequency, then you could narrow it down to a specific value.
Yeah, good, thank you.
Okay.
Great job, Don. You've obviously done a lot of research on this, and the presentation is excellent.
Thank you very much.
Good.
Don,
Very
I got a question.
Can we
Yes.
stop sharing the screen there? Just
Oh. Absolutely.
there we go. Okay.
Don, in your research, did you consider anything in the Canadian Electrical Code? Because there's a whole section on section 54 on the code on transmitters and receivers for amateur radio.
Section 54 and section 10. Section 10 is mainly grounding and bonding as well.
Yeah.
And I was thinking about delving into that, but I didn't want to get too heavy into the code rules and thou shalt do this, thou shalt not do that. And, you know, I wanted to try and just give a little bit of an overview and, you know, a little perspective as to how important it is to look at this. And, you know, if the individual wants to take it further, there's a lot of reference material out there.
No, the like the 2018 code, there's some things in there that when I redid my shack, I went through the code. And I says, whoa, I'd never done that before. And so, which I did. So,
Yeah.
One more question, Don, with regards to grounding and bonding, did you consider, or did you think about talking about common mode current flow on the coax from the antenna?
I did, and I was thinking that with time constraints and that, like I say, I just wanted to give a general overview of the of the topic, but
because that's the problem I have with, like, say, with in-fed antennas and even off-centered fed dipoles, is that, you know, you have to put some RF choking in there, otherwise you'll get common mode currents coming in.
Yep, the old ferrite bead syndrome.
Yep.
Yeah, no, I could have extrapolated on for probably an hour and a half, but I don't know how many eyes would have been opened by the end of that.
Yeah. No, good job, Don. Thank you.
Thank you.
Murray, I have a question for you, Murray. What was it that you discovered in the code that you hadn't done before? What?
Number one, proper size of ground wire. You need a minimum of number 8.
Number 8. Okay.
That is, and as Don says, keep that as close to your shack as possible.
Yep.
You know, right now mine's about 20 feet. So by the time it goes up from the shack, out, and then down onto the ground loop. So.
Okay.
And also, like what Don showed there, that ground bar. I put one of those in. I actually built it. Well, I had a ground strap from an old panel. It was actually a nice copper bar. So, and then I drilled them about half an inch apart, and then put 10 30-seconds in it. So 10 24, sorry. And you know, like Don says, is that have that one common point of for your groundings, rather than, you know, having separated, like even a foot will start to give you problems.
I like the idea of that coax cable put in place where it's necessary to have a long length of wire. That was an excellent thing. I've never seen that before. That's great, Don.
Yeah.
Thanks, guys.
Maybe I can use my old piece of FT4 on that.
I'd like to just interrupt and welcome my neighbor Joe, who joined the meeting during the presentation.
Hi, Joe.
Hey, Joe.
Hi, Joe.
Any other questions for Don? Yes, Bernie. Microphone, Bernie.
How about that? In your figure 2, you showed that the desirable configuration where all the ground wires from the various devices go to one point.
Yes.
Now, if you have 100 watt and a 1 kilowatt 100 watt transmitter and a 1 kilowatt transmitter, there may be some currents, RF or otherwise, flowing through those short ground wires. So the cases of the two devices are at a different potential. And now you connect the two via a coax cable or so together. That makes the current flow through that coax shield. Does that have any effect?
I'm not quite following you, Bernie. We're talking about figure 2 with the single point ground, correct?
Right, but there is a wire between the single point and the case of the devices. And there could be some RF or some other leakage current flowing through.
Oh,
And
okay.
it's not a 0 ohms, there is still very small. There may be just a few millivolts, but that brings the potential of the two cases at a different potential. And if you connect the two together with a audio or with a audio cable or with something else, you get a current flowing through that audio
But
or a
that
coax cable.
would be a different source.
Yes, it
Your
would be. Yes,
your
yeah.
ground or your bonding system, because we are bonding here, we're not grounding. Your bonding system would still provide a 0 voltage, like an equal voltage between all interconnected equipment.
Yeah.
But if you have say say you have a bad ground on the audio,
Yeah.
and it will jump over to the next piece of equipment in that respect.
All right. Yeah, yeah, yeah. So it could cause some problems if.
That could, yes, yeah.
Yeah.
Once again, you would have to do a little troubleshooting and just ensure that your voltage is referenced to 0, and it may be as simple as a shield.
Okay.
I hope I answered that.
I think maybe if you placed all your equipment in a circle and had all the ground wires or the shortened ones the same length to that center point, you'd have it beat, right?
Yeah.
You could sit in the middle of all your equipment.
Yes. Yeah.
Actually, if you add RF as a source that you're trying to ground, you probably should be choking feed lines so that no RF comes back on no common mode RF comes back on the shield of the coax and interferes with the system with one other power source, the RF coming back from the antenna or from a badly built transmitter, RF coming out from the transmitter in a spurious way.
Mm-hmm.
Grounding is probably one of the biggest system specialties that are ignored. And we didn't even talk about every ground in the site has to be grounded together.
That's right.
And the grounding conductor has to be number 6, copper.
Minimum.
Yep, with all underground connections, brass or welded together. Grounds are very difficult to troubleshoot if you don't plan for success, but allow failure to sleep in to the system.
Exactly. It really is a topic that can be taken to the nth degree, and you can get so caught up in chasing your tail on it, it's not even funny.
Yep.
Any other questions for Don? Again, Don, thanks very much for doing
I think
that.
Dave had one, Jerry.
Jerry?
Oh, sorry, didn't see
I must say, I found Don's talk very illuminating, but there's one aspect of it that I did find quite shocking. And that aspect is on the wall behind him, we can see Don's bare bum.
Better?
Okay. Anything else for Don? A little less shocking. Okay, well, thanks very much again.
Right on.
Let's move on to new business.